Okay, so for horizontal and vertical components, we're basically looking at the x-axis and the y-axis. That's how I think about it. So we have Danica, and she is pulling a sled with a force of 400 newtons using a string. If the string makes a 35-degree angle with the ground, so let's think about this. Okay, it has to make a 35-degree angle with the ground. Oops. Let me try that again. So here's our ground. Okay, here's our 35 degrees. Okay, and then we have the incline, or the hill. Or I'm sorry, the string makes a 35-degree, whatever, that's fine, same thing. It says find the magnitudes of the horizontal and vertical components. So when we say horizontal, show me with your arm what horizontal looks like. What's horizontal look like? Yeah, here. Okay, I always think horizon, like this one. Okay. So horizontal's here. Horizontal is typically our x-axis, so we're just going to label that x. Okay, and then vertical is straight up and down. Okay, that would be something like a y-axis, so we'll label that y. Now, we know that our force is 400 newtons. So when you're doing these problems, whatever measurement they give you like that, that's going to be your hypotenuse measurement every single time. Okay, so we're going to do our cosine, and we're going to do our sine of both. And we always do it of the angle. So cosine of 35 equals, and cosine is adjacent over hypotenuse. So what is adjacent to our 35 degrees? X. Okay, right here. And then over the hypotenuse, which is 400. Now, I'm going to add something in here. We don't want to have anything that's a negative distance. So if that happens, we want to make it positive. So we're going to throw in an absolute value symbol. Because when we get to the end of solving for x, we want to make sure it's positive. If that bothers you, and you would rather just do it as normal, and then make sure it's positive, just change it to positive at the end, I'm fine with that. Whatever you prefer to do. Okay, before we do sine, I'm going to go ahead and solve my cosine here. Okay, so to solve for x, do we have an idea on how we would solve for x here? Get x by itself. Yeah, get that 400 on the other side. So since it's being divided, we're going to multiply both sides by 400. So we're left with 400 cosine of 35. And we can just put that in our calculator. Again, if you don't like the absolute values on your x, that's fine. Just make sure your answer is positive at the very end. Okay, so we have 400. Oh, gotta check my mode. Okay, so 327 point, we'll just say 327.7. Now, what are we talking about here? We're talking about, I think it should be newtons. Let me make sure. Or is it in pounds? Yep, newtons. Okay, now, if we just solved for x, is that the horizontal or the vertical component? If you look up here. Horizontal or vertical component? Horizontal, right? It's the flat one, right here. So that's horizontal. Okay, I'm going to go ahead and do the sine. All right, so sine of 35. Sine is opposite over hypotenuse. What's opposite of our 35 degrees? y. So we're going to do y over the hypotenuse of 400. Same deal, you're going to multiply both sides by 400, get that y by itself. And that's our vertical component. And that's all there is to these problems. I really don't think they're too bad. Just gotta make sure you get that set up right from there. Questions for me before we do 16? All right. So Ken is running 6 miles per hour in the direction of south 70 west. Okay, so south 70 west. Let's see, we have west, south. So that would be 70 there. This one takes a little bit more to figure out than the last one did, but that's fine. It's not too bad. So think about it from the horizontal. Okay, let's extend. We've been working with only that right side of the horizontal. Let's extend the whole thing. If we extend the whole thing, here's our triangle that we want to work with, right there, okay? So we just have to figure out, if this is 70, what does that make this angle? 20. It's a 20-degree angle. Okay, and they told us that Ken is running 6 miles per hour. So like I said, that's always going to be the measure of your hypotenuse. And then our horizontal component, the one that looks flat like the x-axis, we label that x. And then our y-axis, or that vertical component, we label y. That doesn't look like 20 degrees, but that's okay. Okay, so cosine 20. What is adjacent to our 20 degrees? X over your hypotenuse of 6. And then our sine is y over your hypotenuse. That's going to be pretty standard. Most of the time that's going to work out that way. Okay, so to solve for our cosine, how are we going to get x by itself? Yep, multiply by 6. So in your calculator, you do 6 cosine 20. What are we dealing with here? Miles per hour? Yeah. And over here, same thing. Multiply both sides by 6. So there's your vertical and horizontal component. Which one is horizontal? Which letter? X. X will always be horizontal. And Y will always be vertical. Okay, tomorrow, or you can do it now if you want to, we will do question number 6 and 7, 8 and 9. 8 and 9 are what we just did. Okay, so if you want to work on this now, you can. I'll give you a little bit of time at the beginning of class tomorrow to kind of warm up with those, okay?